Hey everyone, in this tutorial we'll be discussing about thyristors. So what is a thyristor? A thyristor is a semiconductor device. It has four layers of alternating P and N type materials. It is a family of devices used for high power applications. And SCR is the most popular device of the thyristor family. So it's a semiconductor device. Semiconductors are those materials whose conductivity lies between conductors and non-conductors, that is between metals and insulators. And the two most popular semiconducting materials used widely are silicon and germanium. And you'll find these semiconducting materials in most of the electronic devices. Next point, it has four layers of alternating P and N type materials. Now what is this P and N type material? Our semiconductor is divided into two types, that is intrinsic and extrinsic. Intrinsic semiconductors are those without any impurities, means they are in the pure form. And the second type is extrinsic. Extrinsic semiconducting materials are those type which have impurities. That is, impurities are also called as dopants. Here we'll be discussing about the second type, that is extrinsic semiconductors. Now the dopants or the impurities, they are also further divided into two types. First is pentavalent and second is trivalent. Penta means 5 and tri means 3. Pentavalent doping materials are those type of materials that have valency 5, and same with trivalent. Trivalent doping materials are those which have valency 3. Now this pentavalent type of dopant, it is added in P type material, and trivalent doping material is added in N type of material. Pentavalent is added for P-type material and trivalent is added for N-type material. Third point, it is a family of devices used for high power applications. Now this thyristor family, they can handle high voltage, means they can withstand high power and high voltage, and hence they are used for high power applications. And the fourth point, SCR is the most popular device of the thyristor family. Now this thyristor family, they can further be divided into two parts. So thyristors can further be classified into two types, that is triggering devices and power control devices. But we won't be discussing it here because our major focus is on SCR. So all lights on SCR because it's the most popular one. Introduction to SCR. SCR stands for Silicon Controlled Rectifier. They have the highest power handling capacity of all the power semiconductor devices. It's a current controlled device because the gate current controls the SCR. It's a latching type device that can be turned on by the control terminal, that is the gate terminal, but once turned on, the gate loses control of it. Here's the symbol of SCR. So the full form of SCR is Silicon Controlled Rectifier. So what is a rectifier? Rectifier is a device that converts alternating current into direct current, that is AC to DC. And for this purpose, they use diodes. So here we have this diode here. This is the symbol of diode. And now obviously if it is silicon controlled rectifier, so it will be made up of silicon. Talking about rectifiers, we have other type of rectifiers like half wave rectifier, full wave rectifier, bridge rectifier. So the question is, why do we use a SCR, that is specifically silicon controlled rectifier? Why should we use silicon controlled rectifier when we have other rectifiers as well? Now other rectifiers like half wave, full wave or bridge rectifier, they normally have two layers. They have two diodes, that is P and N. So if we apply high voltage, it gets destroyed. The device, it gets destroyed. These rectifiers, they don't work on high voltages. On the other hand, silicon controlled rectifier, it belongs to the thyristor family, and as discussed earlier, it has four layers PNPN. As discussed earlier, it has four layers of P and N type material. And Thyristor family, it is used for high power application. So SCR can withstand high voltage and hence it is used for high power application. Talking about the second point, they have the highest power handling capacity of all power semiconductor devices. As I said, SCR belongs to the thyristor family and hence they are used for high power application since they can withstand high voltage because of their four layer construction of alternating P and N type material. It's a current control device. Since it's a current control device, SCR, they are used in devices to they are used in devices which have high power and we need to control that power. And the gate terminal, the gate current controls the SCR. Fourth point, it's a latching type device. Latching means stable state. It can remain in a particular state, that is in an on state. So our device can be turned on by the control terminal, and control terminal is nothing but the gate terminal. And once it is turned on, the gate loses control of it. That means the gate gate terminal is no longer gonna control our device. It will remain in the on state. This is what is meant by latching type device. And then further, it cannot be turned off by the gate terminal. Last point, this is the symbol of SCR, where we have this diode here. We have three terminals, that is anode, cathode and gate terminal. Anode is positive, cathode is negative, and the gate terminal is the control terminal. So the gate terminal is the terminal that controls the current, the flow of current from anode to cathode. Now we'll be discussing the construction of SCR. It is four-layer PNPN device. It has three terminals that are cathode, anode and gate. The gate terminal is the controlling terminal and it can turn on the device whenever required. It has three junctions, J1, J2 and J3. To turn on, SCR should be forward biased. The direction of anode current and gate current are conventional current direction. It's a unidirectional device and gate current can only be positive. So the first point that says it is four-layer PNPN device. What does it mean? It means that as discussed earlier, thyristor, it was four-layer alternating PNPN material. So same goes here. SCR, it also has four layers of alternating PNPN material. So you can see this here in the picture shown here. This is the basic construction of SCR and it has four layers of alternating PNPN. That means P and N type materials are used. So now our device has three terminals. that is cathode, anode, and one extra terminal, this is gate. Now why I call this as extra terminal? As seen earlier, if you are talking about a diode basically has two terminals. One is cathode and here, and then one is anode. But as in terms of SCR, SCR has an extra terminal that is called as the gate terminal. And this terminal, the gate terminal, is the one which is responsible for controlling the flow of current from anode to cathode. Here you can see it has three terminals. One is anode, one is cathode, and one extra terminal. This is the gate terminal. And the gate terminal is the one which controls the flow from anode to cathode. So anode is positive and cathode is negative. So current flows from higher potential to lower potential. So here it is stated here in our third point that the gate terminal is the controlling terminal. Can turn on the device whenever required. So gate terminal is the one which is responsible for turning on the device because it is the one which is controlling the flow of current. The fourth point says that it has three junctions, J1, J2 and J3. Here you can see J1, J2 and J3. The first junction, that is J1. J1 is between first P layer and first N layer, whereas junction J2, it is between first N layer and second P layer, and junction J3 is between second P layer and second N layer. So the fifth point states that to turn on SCR should be forward biased. What does this mean is our anode should be at higher positive potential as compared to the cathode. When this side is at higher potential than this side, means positive side is at higher potential and negative side is at lower potential. That means our device is in forward biased state. Next point, the direction of anode and gate current are conventional current directions. Conventional current means conventional current is a direction of flow of positively charged particles. That means both will be positive in simple terms. So here the previous point is covered in the last point. It's a unidirectional device and gate current can only be positive. So the current will be flowing in only one direction and hence it is called as unidirectional device. And as said earlier, gate current can only be positive. It can't be negative. Now we'll be discussing the operation of SCR. Basically, we'll be discussing two modes of operation, that is forward blocking capacity and reverse blocking capacity in the next slide. Here we'll be focusing on forward blocking capacity. First point, anode is positive, cathode is negative. J1 and J3 are forward biased, J2 is reverse biased. So this one is quite simple. Our SCR can be said in forward blocking mode when anode is connected to the positive terminal of the battery and cathode is connected to the negative terminal of the battery. At that time what happens is that our J1 and J3, here J1 and J3, these two junctions, they are forward biased, and the junction between, that is J2 is reverse biased. Now we'll be discussing the second mode of operation, that is reverse blocking capacity or reverse blocking mode. First point, anode is negative, cathode is positive, J1 and J3 are reverse biased and J2 is forward biased. Now unlike forward blocking capacity, the connections here are made inversely. That means anode is connected to the negative terminal of the battery, whereas cathode is connected to the positive terminal of the battery. Hence junction J1 is reverse biased and junction J3 is also reverse biased, and junction J2 is forward biased. So this condition is called as reverse blocking capacity. If my video has helped you in any way, do hit that like button and subscribe for more such videos. Thank you.